So the examples we saw last time hopefully give you some motivation as to why expected values are something we're interested in. The catch is they often kind of end up running into some problems. So I talked about deal or no deal before, and in a classroom setting, I'll often sort of run through a demonstration of what a deal or no deal game looks like in terms of expected values and how to make decisions. The challenge I'll run into is very often my students just kind of end up looking at it as no matter what, I'm going to push through until the bitter end because, hey, no matter what's in that case, it's more money than I had when I came into the studio. So I wanted to take a look at some examples where you actually have some skin in the game, so to speak, or in other words, you stand to lose something if the experiment ends up not going in your favor. So, for instance, if you imagine a deal or no deal thing, maybe you need to make a certain amount of money to come out on the positive side from travel expenses or something. Anyway, so surprise, we're going back to the gambling well. So we're going to be talking about a few roulette bets. So I've included an image of a roulette table in the PowerPoint slides. I've also given you that reference from back at the beginning of Chapter 3 about the payout odds of various roulette bets. So keep those handy if you're not super familiar with it, which is okay. I looked them up myself. Anyway, so hopefully you're familiar with sort of the standard structure of roulette: spinning wheel, ball stops on a space on it, people place bets, that kind of thing. All right, so the first thing I want to take a look at is what you might call the single number bet in a roulette wheel, or on a roulette table rather, or I think they call them straight bets if you prefer. You basically just put your entire wager on a single number, and you are banking everything on that one number coming up. So that has really, really high payout odds if you look at what's going on. I'm going to stick to just doing like a single dollar wager because that's really all we need to focus on here. So anyway, so we've got, following our expected value format from before, we really only have two outcomes. Either our bet pays off and we win, or we lose our wager. So the loss looks like -$1 if we're only spending a single dollar chip or what have you. On a win, we technically would get back $36, but one of those was what we bet in the first place. So you can actually just kind of look at the payout as being a net gain of $35 in that instance. It pays out at 35 to 1 if you need to figure out how to read those payout odds. All right, so those are our possible outcomes. In terms of probability, if we take a look at this, there's only one space on the wheel that pays off our bet. On an American wheel, there are 38 spaces in total. If you were in Europe, there's one fewer space. Don't worry about that now. Now, every other space on the wheel is a loss for us. So we have 37 over 38 is our probability that we lose our buck. All right, so now we've seen expected value says I multiply each of these guys together, then I add them up. So 35 times this gives me 35 over 38. -1 times this guy is -37 over 38. So instead of adding, I'm really having to subtract this number from here. That's -2 over 38. If you reduce the fraction, that's -1/19. If you want it as a dollar figure, it looks like -0.053 if we go out to 3 decimal places. So yeah. Now what this ends up meaning in the long run, that should be a -0.053. That's important here. So the idea is, in this instance, we have a negative expected value. In the long run, we're basically expecting to lose a little more than a nickel on every dollar we wager. If you imagine we just keep sitting there and placing the same chip on the same number over and over again. So that's the format. So surprise, the casino has an advantage here. You might call that a house edge, so to speak, on the bet. Anyway, now, suppose we want a safer bet. So you might try what we call a 4-number bet, or a corner bet, I think is the fancy, math speak. Or, I say math speak, I should say casino speak. So, I'm trying to preserve my table here. I'll probably regret that later. So, the 4-number bet, its payout odds are lower because it's safer. So, it actually only pays out at 8 to 1, so we net profit $8 if our bet comes out in our favor. We still lose the $1 bet if it comes out on the downside. So now, as it turns out, we're covering 4 numbers. So there is a 4/38 probability we win, every other number is a loss. So again, remember the probabilities inside this table should add up to 1 when it's all said and done. All right, so multiplying down, these guys give me 32 over 38 minus 34 over 38 from the second part of my table, and we're back where we started. So we're still expecting to lose a nickel per bet even when we went safer on this. It's almost like they know what they're doing. Anyway, so let's try going with an even safer bet. So there's all sorts of bets sitting around on a roulette wheel. We're going to take some of the ones at the very bottom. So a lot of the numbers on the wheel are colored red, and you can actually bet on whether it comes up red or black, in terms of the coloration there. So again, that's going to change our calculation up a bit. In this instance, if you go for the super duper safe bet there of just banking on it being red, that pays out of what you call even money, so you're really only profiting a buck. Now there are 38 spaces. 2 of them are green for what that's worth. So yeah, they're neither red nor black. So we have an 18 out of 38 probability that our bet pays off if we bet on red. Again, and you might be able to see where this is going, we have a 20 out of 38 probability that it lands on something else. Yay! 18 over 38 minus 20 over 30. Yeah, we're back to negative 2 over 38. We are still sitting on losing a nickel for every one of these. So not all expected values on a roulette wheel are going to come out to this. A lot of them are. I do encourage you to check it out if it's a different, sort of bet arrangement that you end up seeing in a homework problem or something. They don't get any better, I can tell you that much. So, yeah, pretty much every bet on a roulette table is what you'd call a losing bet in the long run. The house has an advantage. Generally speaking, if you're in a casino, if they're offering you a bet, they probably have an advantage on it. Anyway, so that's roulette. I wanted to take a look at one last example that, again, is kind of like a real world sort of analog of this thing. So, you see in the slides, there's a problem involving a lawsuit being filed. Product liability, I think, is the setting I've given it here. So a company is facing a lawsuit. They've gone back and forth, and there's finally sort of like the firm and final settlement offer before they go to court. So the settlement offer is $300,000. If the company is willing to sacrifice $300,000, whatever problem it is just goes away. On the downside, if they go to court, they're possibly going to be out $700,000 if the court finds in the other, in the plaintiff's favor, so to speak. I don't know if plaintiff is the right term. This is like a civil case, so grievant, yeah, whatever. All right, so let's assume they go to court. All right, so in this instance, our company is potentially out $700,000 if the court ends up finding against them. Now, being a corporation that's big enough to face a product liability case, they've got a legal team who's worked on this, and it says there's an 80% chance that the court ends up finding us not liable for some reason or another. So that means there's only a 20% chance that this ends up happening. So as a probability, that's going to be 0.20 if you want to write down the zero. On the other hand, it turns out, possibly, if the court finds in our favor, we'll assume legal fees and stuff are already covered by the fact that this corporation is big enough for a legal team. And that's where the 0.8 probability, the 80% chance, comes up. All right, so now, assuming we go to court, our expected value of multiply these two guys together, negative 700,000 times 0.2 is negative 140,000. Still sounds like an ouch. Plus 0 times 0.8 So we'd have an expected loss of $140,000. So I mean, it's still negative. But in practice, if money is the only concern, and you're not dealing with like some kind of media circus publicity thing, this is still less than what we would be out if we settled. Right? We're guaranteed to lose $300,000 if we settle. So again, if the dollar signs are your only concern, you probably want to take your chances in the courtroom. So that's expected value. All right. So we've got a couple more sections of material to cover. There's actually not a ton in the very last one, but they kind of end up building on each other in terms of a different way to calculate probabilities. So we'll talk about that momentarily.